All right, so there were just a few more things in chapter 5, and we really had already covered them. And one was the idea of the C_str call. See if I still have that open here. Right. C_str. What that does is it returns a pointer to the array representation of the data. And what does that mean? Well, back in the olden days, dating all the way back up to good old C, invented in the 1970s, 1970, here's how you declared a so-called string. It was a character array. This is saying that I need a variable called name, and it has to have enough for 20 characters. Really, it only has enough for 19 characters because the last character is a 0. It's a hidden character. It's a null. So if we did name, I'm going to change that to an E just for giggles. 20 is equal to ABE. What we really have is the characters, and we could go to ASCIItable.com and look them up. The A, there's a 65 stored there in the first one in position 0. There's a B, which is a 66 stored in position 1. And then there's a 69 stored in position 2, right? So 0, 1, 2. And then how does the computer know when to stop sending, right? If we did cout less than name, if we were sending that data to the screen, how would it know when to stop? Well, it doesn't stop, because it hit the quote. No, because the quote just marks what the compiler sees, not what the computer sees. For the computer to know when to stop, there is a hidden element stored in the last position of that array, or, consecutively. So in position 0, 1, 2, in position 3, there's a 0. There's a null hidden there. And if we looked at ASCIItable.com, then we would see it labeled as null. Right? There we go. So A, B, C is 65, or I said ABE, 65, 66, 69, and then the next position is a 0, just so that it knows. And then say we wanted to change the first position to an X. We can do that, right? We can say, okay, I want to change the first character. You start counting at 0. That's 0, and that's 1, and that's 2, to an X. And then it equals XBE, except that wouldn't work. It would probably need to be that. Yeah, because if you're going to denote a single character, you have to put apostrophes around it. And then we want to add some more letters to it. Well, we can do that up until all 20 characters are used, or all 19 characters plus the 0 terminating one. So we could go ahead and concatenate, meaning append, the letters BOB to the string. And in that case, we get XBE, right, because we changed the first one to an X, and then BOB because we've added that. And so now this string has 6 characters, and then behind the scenes, there's that null in the next place. There's that 0 in the next place. So that's position 0, 1, 2, 3, 4, 5, and then at position 6, there would be that null. And we could write that out as a little bit of code just to prove that it works that way, right? Character name subscript 20 equals Bob, right? Or Abe, I think I had. And then we're going to change the first position to an X, right? And then we could see it out. That is, of course, if we have done using namespace std. Don't need that hello world. And by the way, gang, when you turn in your source code, please go ahead and delete these comments down at the bottom, right? They're just useless noise. You know how to create a project, and so do I. So just delete that stuff. And what you should also do is go to the top, and instead of saying this file contains the main function, you can delete that and put your own name there, right? This is, CIT1173, and then put your name you know, my name is Jeff Thompson, and, you know, put, you know, homework 5 or lecture K or whatever it is, right? Okay, so of course you'd put your own name there. I'd like for you to do that for your homework. Put a header block here, you know, describing what class it is, maybe the date that you turned it in. That's not strictly necessary, but there wouldn't be anything wrong with doing that. You know, putting your name, putting your homework assignment, and putting a description of the homework assignment. You could just copy and paste straight from the instructions if you wanted to, usually. All righty, so when we print this out, it's going to say XBE, and then if we use strcat, and this may actually give me a warning, it may not compile because this is considered an unsafe function. So if I string cat, if I concatenate Bob to this so-called C string, this is a null terminated character array, also known as a C string because it was invented, you know, for the C programming language back in 1970. Let's see if it'll compile. Sometimes string cat and string CPY, which means copy. Yeah, it doesn't want me to do that. Let's see if it offers a suggestion for fixing it. Let's find the errors. View the error list. Yeah, see, it says this function may be unsafe. And the reason why is string cat doesn't know. This is better had only contained 19 characters plus a null. So if we copied too much into it, you know, that's well over 20 characters at this point. Then we've written past the end of the array. We've corrupted memory. So this wants me to use strcat_s. I know you can't read it because it's teeny tiny, but let's give that a shot. strcat_s. All right. And at least it failed, right? It didn't corrupt memory and then keep running on. That's your nightmare, is when the program corrupts memory, but it doesn't crash. And then later on, something goes wrong, right? Like you write a paycheck to somebody and the, you know, it's got the amount wrong because some memory got corrupted. You issue them a check for $900,000 or whatever. Or it crashes a program, you know, at some unexpected point and your Mars lander, you know, crashes or whatever. So anyways, so it's telling me that the buffer is too small, and that's because I used string cat_s. It knew that I went past the end of the array, and that's nice. It's nice that it caught it. Anyways, wouldn't have done that if I had copied something less than that, right? Because I have 19 characters plus the null to play with. So now it should say XBEBOB if I send it out to the screen. Right, we see XBEBOB. Now let's print it out via its ASCII values with a for loop. I'm going to use a while loop instead. What I'm going to do is I'm going to say, if the character that we're printing out is a 0, it's time to break the loop. So we're going to start our counter, our index. I'm just going to call the index I. Int I is equal to 0. And this is not normally how I would write it, but it's going to be easy to see, right? So while true, see out that character. See out the integer version of the character at position I. Oh, and it's hung on me. Okay, name the character at position I. I guess I could also see out, you know, a space and then just see out that real character and not the ASCII value of it, right? So that we'll see them both. And then if name subscript I is not equal to 0, then break. Excuse me. If it is equal to 0, then break, because we're at the end of the string. Now, if you look at it, this is a post-test loop, is it not? Right? It's a post-test loop. So I could rewrite it to this. Do this stuff, all this stuff, right? while name subscript I is not equal to 0. Get rid of that semicolon there. It's actually supposed to go there, but we better increase I, right? Or else it'll just keep doing the same one over and over and over. All right, so this is going to print out the string, every letter in it, and printing out that terminating null, just so that we can see it. Right? XBEBOB. We didn't get to see the terminating null, though, because it was a do while loop, right? And so once it found out that it was that, so what are we going to do about that? How are we going to make this work? I guess I could start I off at -1. I don't think this is going to work either. Maybe I should have just did it the way that I was going to do. While true. Okay, I'm going to cheat. And I know the length of the string, really. The length of the string is 6 characters. And so I'm going to keep going while I is less than or equal to 6, which is actually going to count 7, right? 0, 1, 2, 3, 4, 5, 6. If I counted out on my fingers, that would be 7 fingers. Okay. So that'll do the trick. I don't know why I couldn't think of another way of doing this, but that'll do the trick. Right, and so here we have the ASCII values for XBE, BOB, and then the terminating character is just an ASCII 0, right? It's just a null right there. So that's called a C string. Now, these are hard to work with, right? Because we have functions like that, and you have to worry about the length of the array and correcting memory and stuff like that. And so that's why they created a string class. Right, so that you could do that. And if you want to change the first letter to, you know, a C, his name is Cobb, not Bob. Like that, right? And then you want to add something to it, you know, S name plus equals, you know, space Roberts. There, now he's got a last name, Cobb Roberts. Sounds silly, but anyways. Then if you ever needed a pointer to it so that you could treat it like it was a C array, you could. So we could do that if we wanted to. Char star pointer to S name. We haven't talked much about pointers. Is equal to S name dot C underscore STR. And then we could do the same thing that we did here, right? We could have a while loop that did it. It's not liking me doing that. What is that error? Okay, it wants me to make this a const because we're not allowed to change the values inside the string using this pointer. We should change the values using the string itself and not using this pointer. But anyways, now PS name is just exactly the same kind of thing that name is, and we can refer to it with a for loop like that. How many characters is this supposed to be? BOB is 3, and then a space is 4, and then Roberts is 3, 4, 5, 6, 7 more. And so we need to go while it's less than or equal to 11, and we could print out that value, right? PS name subscript I plus PS name subscript I, right? And I have an error. Oh, multiple initializations. I already had a variable called I up here, right? So down here, can't recreate it. Guess that's what that line is telling me. Error there. All right, let's go. Right, and then we see Cobb Roberts, and there's a terminating null there. So behind the scenes, the C++ string class, the string object, is storing its data internally the same way. It's just got a lot more flexibility in how you use it because there's a whole bunch of methods attached to it. You could look up the C++ string class and find out all sorts of information about it. C++ string class methods. It's got functions like begin and end and size and length and maximum size and resize and clear it if you want to empty it out. You can insert into the string. You can replace parts of the string with another string. You know, you can copy parts of the string. You can find something in the string. It's got all sorts of things. We could spend a whole day just talking about the string class. Yeah, maybe we will. Okay, so why do you care about that C string function? Because normally you're not going to do that. But what if we had written a print function that looked like this for whatever purposes? Void print const char star sz for zero terminated C string, right? Well, you know, and this could C out SC and then go like that, right? Looks normal, except this is a pointer to a C string, right? It's a character array. Now, if I called it because I wanted to print out that name, print PS name, it might give me a compilation error. It might say, I don't know how to convert that data. Now, I believe that it actually does know how to convert the data. I don't think that I have to do the conversion myself. I think that as of C2011, the version approved in 2011, you don't have to do that. But you might be programming in an older version. What happened here? Forgot my semicolon there. Thanks. It was there earlier. All right. So anyways, and so it did display it to the screen. It worked. If I was using a version before the standard for 2011, if I was using something earlier than C11, then I would have to do this. .c underscore string. Now what are you complaining about? Maybe it wants that. No. I want to be using the actual string and not the pointer to it. So that's why it actually worked, just because I already had the pointer to it. Yeah, see, now it's complaining because I have a string here, but it's expecting a C string here, right? It's wanting a C string there, but it's easy to convert. sname.c underscore str, parentheses in parentheses, fixes it. Pass the data as a C string. Fixes that. All right. And I know that we talked about break and continue, so we can skip the last 2 pages of the slide. We've talked about break and continue. So let's go to the next chapter, chapter 6, functions. Now we know about functions. We've been using functions. Defining and calling functions. When you define a function, you need to give it a return type, a name, and a parameter list and a body. Do I have all 4 of those things in my code? If I scroll up here and I look at that print function, right? Yeah, it's got a return type. Void means it doesn't return anything. It's got a name. It's got a parameter list. And if there was nothing between the parameters, you just don't pass it any arguments. And then it's got a body, right? Let's write another function. Here's one called add to, which takes 2 numbers, int x and int y, and int result is equal to x plus y, and it returns the result, right? So whatever's being returned has to match or be easily convertible to its return type. If I don't make it return anything, it's not going to compile, right? Because it has to return something. It's declared as having a return type, it better do so. If I really didn't want it to return anything, I could do that, right? But then it's silly, right? We're adding 2 numbers and we're not doing anything with it. So let's go ahead and do that, right? So now it adds those two numbers and it stores the result in that int, and then it returns that result. So we can call it if we want, right? Int x is equal to, add to 100 comma 200, and if we printed it out, x would be 300, of course. So we've seen that. int main parentheses in parentheses. Main should return a 0. Microsoft C and some compilers will go ahead and compile even if you don't make it return a value, but strictly speaking, you should. And I don't know why they allow it to escape without a return statement, why it doesn't flag that as an error. And so that's the return type. That's the function name. There's a parameter list, but as it notes, it's empty. And then it's got a body between this curly braces. And it does something, and it's got a return value that matches the return type. So if a function returns a value, it must be indicated. int needs to return either a 0 or a non-zero value. The operating system or a calling script could check that return value and do something with it. If it doesn't return a value, declare it as void. For example, a function called print heading, all it does is see out something. It's not returning anything, so we just declare it as void. We did that up here with this print function, right? Print a C string function. What you complaining about there? It says declaration incompatible with void const char declared in line 8. Is that a spurious error? Is it going to go away as soon as I compile it? Yeah, of course. All right. Yay, error went away as soon as I compiled it. All righty. So we could write another version of the add function that would accept 3 variables. On the other hand, it's called add to. But let's say that I don't want to write versions of this would it accept 3 and 4 and 5 and have to remember to call it that, right? I want the ability to have an add function that takes either 2 or 3 or 4, right? I want the ability to do that. And right now it doesn't, but I'm going to rename this just to plain old add, and I'm going to make a version of it that accepts 3 variables, int x, int y, int z, right? And then result is equal to x plus y plus z. Now, the fact that it has the same name is not a problem. You couldn't do this in Python. Once you declare a new function, it erases the old function from its memory. This one keeps track of the whole thing. This is called its signature, add followed by 3 ints. It knows that if you're going to call add followed by 3 ints, 2, 3, comma 4, which one to do? Add int, int, int. It would look up here and find add int, int, int. So that's going to run this one. Whereas this one is only going to take 2, right? And so it looks for one with a signature called add int, int. Comes up here and it finds add int, int. And so that works. This is called overloading. Overloading is when you have multiple functions with the same name but different parameter lists. That's important enough to actually note in our comments. So let's just make a broad here, right? To define a function, you specify a return type, a function name, a list of parameters between parentheses, which could be empty, right? A body and a body. The body needs a return statement if the function is not defined as void. And then overloading is creating more than one function with the same name, but different parameter lists. And that's our example right here, right? We have one that takes 2, we have one that takes 3, we might want to write one that takes 4. I've already used X, Y, and Z. I guess I'll do A, right? X, Y, Z, and then int A. Maybe I should have called them X1, X2, X3, and X4. But anyways, right? Like that. And so now whenever we want to call it, doesn't matter. We called it with 2 parameters. We called it with 3 parameters. We called it with 4 parameters. And the reason you do overloading is just to make it look clean and easy to read, right? Oh, I'm going to be adding 2 numbers. That's cool. Now I'm going to add 3 numbers. Hey, that's great. I'm going to add 4 numbers, right? And so that way it doesn't matter. Now, what if you wanted to make it so that they would also accept doubles rather than ints? Or if they were going to accept longs? Well, we could do that. We would just copy these 3 functions and then change all the word ints to longs, right? So now I have to find them all. But anyways, you know, let's just do double instead, right? So there's one that accepts 4 doubles. And here's one that accepts 3 doubles and returns a double. And here's one that accepts 2 doubles, right? And so now our code doesn't care whether we're calling it with ints or doubles. It'll work just as well, right? I could do double, you know, y is equal to add, you know, 100.1 comma 200.2. And that'll work just as well. It knows which function to call based on its signature. It looks for a version of add that'll accept a double double, right? Add double double. And so it searches its, you know, the compiler has wired it up so that add double double, so it would invoke this code. Now, strictly speaking, if we did not have these other versions of int, of add, if we did not have the ones that accepted ints, right? The doubles would still work, but it would return a double, right? If I deleted all these ones that had, like if I deleted this one here, so now that we no longer have one called add int int, we go down here and we call add int int, it runs the one with doubles because ints can be converted to doubles, right? So when it's searching for its signatures, it first looks for one called add int int, and if it doesn't find one, it looks for a signature that would accept ints, and the doubles version will accept ints, but then it would return a double, and the compiler might complain that it returned a double, but we're trying to store it into an int. It might not in this language. It definitely would in Java. Hey, let's find out. Let's compile it and run it. I think I saw it say 1 warning. Yeah. Conversion from a double to an int, possible loss of data. Well, that's our fault, right? You know, we knew that this function was going to be returning a double. We should have stored it in a double if we were worried about it. But we made the decision that since these are ints, it's no problem. But anyways, I'm going to undo that delete that I did. So let's add a comment here of what we've done. Overload 6 versions of the add function to accept varying numbers and types of parameters, right? That's what we've done here. This one accepted 2 ints, 2 int arguments, right? This one accepts 3 int arguments, so on, right? I'm just going to copy and paste. That's 4 int arguments. This first one is 2 doubles. The next one is 3 doubles. Do some more copy pasting. And then the last one is 4. So a thing to note is that these are called parameters. And I know I've already said this. When you're defining the function, they're called parameters. But when you're passing data to them, it's easy to get in the habit of saying, okay, these are my parameters, 100 and 200, but the technical name is arguments. That's an argument, and that's an argument. Now, the book will probably mention that you could also optionally say, other computer scientists would say that, oh, by the way, these are your formal parameters and these are your actual parameters, or these are your formal arguments and these are your actual arguments. But everybody knows what you mean if you call this the parameter and you call this the argument. Now, this is one of those chapters that, since we've been already writing chapters, we can go through pretty quickly. When you call a function, you use its name, followed by the parentheses. And then execution jumps into the body of the function, runs, and then when it hits the return statement or the bottom of the curly braces, execution returns back at the point of the call. Right? So when I call add 100, 200, it jumps up to that function matching that signature right here, right? It runs that code, does the body of it. It returns that result. And so then its control is returned back to here, and whatever that returned gets stored into X. Hopefully the value 300, because 100 plus 200 is 300. So main can call any number of functions. And then functions can call other functions. But for it to all to work, the compiler has to know the following about a function before it is called. It has to know its name, its return type, and its number of parameters, and the data type of each parameter. And this is just like Python, where you have to have defined the function before you can call it. However, C++ and C have something called prototypes, which Python does not have. Now I'm going to give you an example. I'm going to go and add a function down here underneath main, and it's going to be called hello, void hello, and it takes a first name, string first, it takes a last name, right? And it just says cout hello, followed by the first name, followed by a space, followed by a last name, followed by an ENDL, right? All right, now our code's going to call it, right? Hello, slim, comma, shady, right? Do that. Doesn't work. Did I already have a function called hello? Is that what this one was called? Way up here? No. Okay, so when I compile it, it's not going to compile. There were build errors. Why? Because it doesn't know what the hello function is. It's calling it before it was defined. Just like if you did this, x, or, you know, if you did s is equal to s plus 2, and then you defined s underneath it, right? That's not going to work because you can't add 2 to something that hasn't been defined. You can't call a function that hasn't already been defined. So we need to define what's called a prototype. A prototype is just a list of the function names, its return type, and then a semicolon at the end, no body. So it was called hello, and it takes 2 strings. That's its signature, right? The function name is hello, it returns a void, and its 2 arguments are string. Now it will compile. If I go down here, run it, now it's going to go ahead and compile. And if I ran it, I'd see the message, hello, Slim Shady, down at the bottom. So that's what a prototype is. A prototype is a function declaration which declares the function type, name, and parameters, but does not have a body. You use it so that the function can be called in the code before it is so-called defined, right? Because our function definition including the body, is underneath main, or it might even be in another file. You're allowed to have multiple .cpp files. Large projects will have dozens of CPP files. A very large project, like, you know, the Windows operating system probably has thousands of CPP files. You know, it's a huge project, I'm absolutely sure. And that's what this is about, function prototypes. You need to notify the compiler about a function before you can call it. So you place a function definition. That's a function prototype. It's a function declaration without the body, right? So the header for a normal function is that, and then there's going to be a body that does something, but the prototype is the same thing and just a semicolon at the end. All right, I'm going to stop this here. It's going to be a short lecture because I want to pile on to this for the next lecture. So I'm going to go ahead and stop here, and we will pick this back up tomorrow.